You know, right under your feet at this very moment, there's a whole hidden world of infrastructure that keeps our modern lives running. These are the unseen guardians of our cities, working silently 24/7. So today, we're going to go deep underground to figure out how one of these silent fortresses is engineered to survive, well, a 100-year war against the Earth itself.
It's a question we probably don't think about much, but the answer is pretty critical. I mean, every time you use a sink or flush a toilet, this huge, complex system just springs into action. But what happens when that system has to fight against the most basic force there is? Gravity.
Well, meet the hero of our story, the lifting station. It's basically a giant, super powerful concrete box that's buried deep underground. And its job? Well, it's simple, but it's absolutely vital. It pumps wastewater uphill. That allows it to keep going on its journey to a treatment plant. Honestly, without these things, huge parts of our cities just couldn't exist. So let's see how this fortress is designed, right from the ground up.
Okay, so before you can even think about building a fortress, you have to understand the battlefield. For engineers, this is way more than just collecting data. It's practically reconnaissance. They've got to know every single threat the ground is hiding before they even draw a single line on a blueprint.
Now take a look at this. This reads less like a soil report and more like an intelligence briefing, right? This isn't just ground, it's an adversary. You got the water table, super high, only 1.5 meters down, which means our structure is going to be constantly underwater. And then look at the chemical content. Sulfates and chlorides, yeah, this isn't just dirt, it's a chemically hostile environment.
Let's just focus on this number for a second. 2.12%. Now that might not sound like a lot, but believe me, in the world of soil chemistry, this is a massive red flag.
So here's what that actually means. This level of sulfate makes the soil itself an aggressor. It is going to spend the next 100 years relentlessly attacking the concrete, trying to corrode it, trying to weaken it. This fortress doesn't just need to be strong, it has to be chemically bulletproof.
So, knowing the enemy is half the battle, right? The other half is forging the right armor. And we're not just talking about mixing some cement and sand here. This is about creating a very specific material that's designed to withstand a century-long siege from water, soil, and chemicals.
And this right here, this is the recipe for that armor. Every single item on this list is a defensive measure. You have high-strength concrete and steel as the backbone. A really low water-to-cement ratio makes the concrete super dense and way less vulnerable to chemical attack. And they do these strict checks on the aggregates to make sure the concrete doesn't start destroying itself from the inside out. Every little detail matters.
But here's the thing. Chemical attacks are only one part of the siege. Our fortress is also going to be under constant physical assault from all sides. So engineers have to calculate every single force, from the constant squeeze of the earth to the violent shaking of an earthquake.
First up, you've got hydrostatic pressure. Remember how high that water table was? Well, that means our structure is basically a submarine. The water in the soil is pushing in with this relentless, crushing force on the walls and the floor 24 hours a day for its entire life.
But what happens when the ground itself starts to move? Well, during an earthquake, the soil doesn't just sit still. It almost acts like a liquid, creating this violent, dynamic pressure wave that just slams into the structure. The earth itself literally becomes a battering ram. So how in the world do you design for all these threats at once? You run a stress test. Engineers don't just design for one force at a time. No, they use what are called load combinations, piling on the water pressure, the soil pressure, the building's own weight, and even seismic forces all at the same time, just to find the absolute worst-case scenario that structure will ever face.
And that brings us to the battle simulations. The design has to be proven safe not just for a normal day, but under every condition you can possibly imagine, especially the most challenging ones.
What's really fascinating here are the two main situations. When the station is empty, save for maintenance, the outside pressure from the soil and water is at its absolute maximum. It's literally trying to implode the box. But when it's full and operating, the pressure from the wastewater inside actually helps push back, which creates a totally different set of stresses.
And then there's this third, kind of wild scenario. Before the fortress is even buried, they fill it with water for testing. This completely reverses the main stress. For this one moment in time, the walls aren't fighting to keep forces out. They're fighting to hold the immense pressure of all that water in. The design has to be able to survive all three of these.
So, after all the analysis, all the calculations, and all the simulations, you need proof. You need cold, hard numbers that show the design isn't just good enough, but that it's overwhelmingly safe. This is the proof of victory.
The first benchmark for success is the factor of safety against sliding. What this means is the structure is designed to resist at least 1.5 times the maximum force that's trying to push it sideways. It's not going anywhere.
Next up, overturning. The design has to be able to resist twice the maximum force that's trying to tip it over. It is locked firmly into the ground.
And finally, the toughest test of all, bearing failure. The fortress is designed to be 3 times stronger than what's needed to support its own immense weight and all the forces pushing down on it. That foundation is absolutely solid.
And this quote right here, it sums up the entire engineering philosophy perfectly. You don't design for the average day. You find the absolute worst, most critical combination of forces you can imagine, and you design your fortress to conquer that.
So from these powerful computer simulations all the way to detailed 3D digital blueprints that let engineers see every single piece before it's even built, the final design is so much more than just a plan. It's a certification that this unseen guardian is ready and able to begin its 100-year watch.
And that kind of leaves us with a final thought, doesn't it? This lifting station, it's just one example. When you look around your city, what other invisible fortresses are standing guard, silently, making your life possible? The engineering is all around us, if you just know where to look.